Okay, so in this section of the module, we're going to look at patterns we can use for the design of our databases and the implementation of our databases so that our databases better support our microservices architecture. And one of the first patterns we want to look at is the event-driven approach, where we use events to share data. And by using events to share data, we're basically trying to avoid having shared databases, monolithic databases between our microservices. So instead, when our microservice needs to share its local data with the rest of the world, with the rest of the applications and services, so when a data change happens within the microservice that needs to be shared with everything else within the architecture, that service then saves the data locally to its data store, but at the same time also raises an event to tell the rest of the architecture, the rest of the system, that this data change has taken place. And the data change is raised as an event to a place where interested parties can basically subscribe to that event. And the interested parties will pick up that data change as an event and might choose to store that data change as local data into the local data store, or they might carry out a task in response to that event. So the subscribing service might store the data locally because for some reason it is of interest to that service. And for example, it might use that data for joins with its own core data in order to satisfy local queries which need to join to that piece of data in order to complete the information required for that service. So it becomes a mechanism to share data with other services. So within our diagram here, we can see that an order is placed using the order service, and the order service will then store the order locally, but at the same time it will raise the creation of the order as an event and place this on to a message queue. And then all other parts of the system, all other applications and services that need to know an order has taken place can then subscribe to that event from the message broker. So in this example, service 3 might be a service which is used to update the stock levels, and the stock levels need to be related back to the order records in order to work out which order took what levels of stock. And service 3 can then choose to subscribe to this event and then also store the order record in its local database so that when other parts of the system need to know which stock was taken by what order, it can then join to that local data. So it's another mechanism to share data with the overall system. The order service has recorded the record locally, but it shared the data with the rest of the system by raising an event. And then service 3 has chosen to store that record locally so that it doesn't need to requery the data from the order services database. So for microservices architecture, sharing data using events is more than ideal. It stops us from creating services that are solely there just to expose a database so that data can be shared. Also, pushing the data out as an event, pushing the data change out as an event, is better than multiple services and applications pulling the data each time they need the data from a service that's creating the data. We basically have better performance in our local microservices database because there's fewer services and applications pulling from the same database, because whoever was interested in that piece of data, we've already let them know by raising an event and broadcasting it to our system. And this method of pushing data is a form of asynchronous communication where we can fire the event and then forget about the event, which again is ideal for our microservices architecture because our service, once it's fired an event, does not have to wait around for a response. And there are also well-established technologies around to support this type of communication, technologies like message brokers. In fact, there's a module on this course titled How to Architect Asynchronous Microservices, where we cover the use of message brokers to handle event-driven asynchronous communication. So the conclusion is using event-driven mechanism to share data changes is an excellent way to share data and also to avoid coupling our architecture, because sharing data by calling services multiple times in order to extract data from another service's database is another form of coupling. But if we broadcast the data changes, we are even more decoupling our overall architecture. In the next section of the module, we will look at event sourcing, which is another pattern around events, which states the best way to store events in a local database.